Morning to all. Today we are going to see about modulation. uh, First, what is modulation? So as per definition, modulation is the process of frequency translation in which any one parameter, that is amplitude, frequency or phase of high frequency carrier signal is varied in accordance with instantaneous value of low frequency modulated signal. So this is the definition. So clearly you can say that. So a signal which is analog, that is a source signal, that is contain information, but it has a low amplitude, which have a, if you have a low amplitude, if you have to, it could not transmit to the long distance, so that we are going for modulation. So modulation which can do that by using the carrier high amplitude carrier signal or high frequency carrier signal, which carry the analog signal, that is the information signals. It vary accordance with the amplitude or frequency or phase of the message signal changed, and it should be transmitted through the medium, and it should be received, and it should be demodulated again, and it can be finally we can receive the original signals. So far we are using that modulation, demodulation to extract the original signal from the receiver side. So modulation we can do that in either analog or digital, both the type. Next one, sampling. So what is sampling? The process of transmitting signals in the form of pulse, that is discontinuous signals, by using special techniques. The signal is sampled at regular intervals such that each sample is proportional to the amplitude of signals at that instant. So this technique is called sampling. Sampling is common in all pulse modulation techniques. So sampling is nothing but we are converting that analog signal into a discretized signal. Discretized, it means it is discontinuous in time. So analog signal is continuous in time nature, so we are converting that into a discontinuous in time with respect with amplitude also. So that we have a different types of process in order to sample the signals. So this is the diagram which shows that the diagram A, which is an analog signal, which have a positive cycle and also negative cycle, which is sampled by the regular interval unit impulses. So this is in the diagram of B, which shows that. So at the time of each interval, the signals which is continued in amplitude, which is discretized or splitted at its corresponding each time instant, and finally we will get the output like B, which is a unit impulses. So while we joining this at the edge of the joining the amplitude of these signals, finally we can get the continuous signal again at the receiver side. So analog signal is sampled every TS time period, that is sampling time period. TS referred as a sampling interval. So where f of s is nothing but sampling frequency, which is equal to reciprocal of time, sampling time. So we have three types of methods in order to sample the analog signal. One is ideal sampling, natural sampling, and then flat top sampling. So ideal sampling is nothing but we are sampling the signal by using an impulse at each sampling instant, which have a constant time instant between the unit impulses. So then natural, it is as a unit pulse of short with varying amplitude, which have a pulses but it have vary with accordance with amplitude. So then flat top. So the flat top is nothing but which has a sample and hold signal like natural, but with a single amplitude value. We can see that in the diagram. So this is the diagram of these methods. The first one, ideal sampling. As I said earlier, it has a unit impulses with constant time interval, that is a sampling time period TS. So uniformly which is distributed in the time period, so which is uniformly sampled at each time interval ts, the signal is to be discretized. So similarly in diagram b shows that which has a unit impulse, the pulse which has short width, but it may vary with the occurrence of, it may vary in the amplitude. So this is called as natural sampling. Then finally third one, flat top sampling. So this is similar like natural sampling. It has a constant width of pulses, but at the left leading edge of the pulse which sample the analog signal. So this is the three kind of sampling methods. Next, sampling rate. The sampling rate, that shows that the Nyquist showed that it is possible to reconstruct a band limited signal from periodic samples as long as the sampling rate is at least twice the frequency of the highest frequency component of the signal. That is, sampling frequency is always greater than that of 2 fm, that is maximum of sampling frequency. So where is f of s is sampling rate, m is the maximum frequency of the signal. So which shows that the sampling rate, in order to reconstruct the original signal at the receiver side, we need to sample the signal at the rate of twice that of the maximum frequency of the signal. If suppose it is not satisfy these criteria, it may result in aliasing or fold over. That is interference. We can also say that interference, that is the clashing of or mixing of signals. It finally corrupts the data. So next, categories of modulation. So we have two types. One is analog pulse modulation, the next one is digital pulse modulation. So in analog pulse we have three types: pulse amplitude, pulse width modulation, then pulse position modulation. In digital pulse modulation we have two types. One is pulse code modulation, then another one is delta modulation. So here we are generally see about the analog pulse modulation. So sampling alone is not a digital technique. We have three types, that is analog sampling modulation. First one, pulse amplitude modulation. The immediate result of sampling is output signal which shows that it's a pulse amplitude modulation signal. So pulse amplitude modulation is an analog scheme in which the amplitude of the pulse is proportional to the amplitude of the signal at the instant of sampling. So that is PAM. The next one, another analog pulse forming technique is also known as the pulse duration modulation. We can also say that pulse width modulation. Then finally the third one is pulse position modulation, is closely related to PDM. Okay, so what are the drawbacks of digital modulation techniques, that is digital communication? Merits and demerits. So digital signals are very easy to receive. The receiver has to just detect whether the pulse is low or high. AM and FM signals become corrupted over much short distance as compared to digital signals. In digital signals, the original signals can be reproduced accurately. The signals lose power as they travel, which is called as attenuation. When AM and FM signals are amplified, the noise also get amplified, but the digital signals can be cleaned up to restore the quality and amplified by the regenerators. Finally, the noise may change the shape of the pulse but not the pattern of the pulses. AM and FM signals can be received by anyone by a suitable receiver, but digital signals can be coded so that only person who is intended for can receive them. So AM and FM transmitters are real-time systems that they can be received only at the time of transmission, but digital signals can be stored at the receiving end. The digital signals can be stored. So this is the difference between the analog communication and digital communication. That is, we can say that merits of digital communication and the drawbacks of analog communication. So next we are going to see about the digital pulse modulation, the process of sampling, which I have already discussed in initially. We have two types: pulse code modulation and delta modulation. So first one, pulse code modulation. So what is pulse code modulation? So pulse code modulation is the most commonly used digital modulation scheme. It is a major scheme which I used earlier. In PCM, the available range of signal voltage is divided into levels and each is assigned a binary number. So first of all, the signal is sampled and each sample level which has assigned a different levels, and it is assigned to be a different binary number. So each sample is represented by a binary number and it transmitted serially. So the number of levels available depends upon the number of bits used to express the sample value. The number of levels is given by this capital N equal to 2 power m. So basically the PCM consists of 3 steps. One is sampling, quantizing, and the binary formatting. We can simply say the formatting the signals. So first, what is sampling? We already know that we are converting the signals continuous into discretized. Then quantization is nothing but a round off the amplitude. So binary encoding is nothing but converting the digital signal into a coded signal. So this is the 3 types. This is the basic block diagram of PCM. First we have get the signal from the source, and it should pass through the low pass filter, and then it's sampled, then quantized, then finally it's encoded, and it can be applied to a PCM signal to the channel. Then it should be transmitted through the medium, which is distorted by the medium. Again it's regenerated. We are using the regenerated repeater because to regain the signal. So it should be again transmitted through the regenerated repeater in between the input and output. So when it reaches the finally channel output, we have a regeneration circuit which get the signal from the medium, and it should be regenerated, and it should be decoded. Finally it should be filtered by using the low pass filter, and extract the original signal as input, which is the same format. So this is the block diagram. The next is analog digital converter employed 2 techniques. One is sampling and quantizing. Sampling, I already know that the process of generating pulses of 0 width and of amplitude equal to instantaneous amplitude of the analog signal. The number of pulses per second is called sampling rate. Quantization is the process of dividing the maximum value of the analog signal into a fixed number of levels in order to convert PAM into a binary code. So this is called quantization levels. So this is the waveform. The first we are having the analog signal. This is an analog signal. It is continuous in nature. So then first we are going using the 3 steps: sampling, quantization, and then coding. The sampling, we are having the instantaneous sampling. The time difference between the sampling pulses are uniformly distributed. So it has different levels, that is different voltage levels. For every voltage we have a different binary values. So at the sampling instant, what is the amplitude of the signal? It should be allocated the corresponding binary code for that amplitude. So for each intervals we are having a different binary code for different amplitude. So finally at the last waveform we have a serial coded signal. So that is the encoded signal that should be transmitted through the medium. So and again it should be extract the original signal by using the decoded format. So this is the PCM working nature. So it has a n number of binary digits are transmitted per sample, as the signaling rating or channel width of PCM are very large. This is the major drawback of the PCM. And it's also encoding, decoding, and quantization circuitry of PCM is complex. This is a major drawback. So in order to resolve this problem, we are going for delta modulation, adaptive delta modulation, and then adaptive differential pulse code modulation. Okay, if you have any doubt, consult me. Thank you.